Hello, this is a video tutorial showing you how to use the TI-83 or TI-84 to find the normal cumulative distribution function. First, let's get a quick summary of what the calculator commands actually are. Here's an example of a normal bell curve. Notice how it's symmetric, but the mean is also in the middle. However, if it's a given value saying that it is less than, notice how it's shaded to the left. Because it's infinite going to the left, our lower bound would be negative 10,000. X would be whatever it's less than, where your mean and your standard deviation are often given to you. If the mean and standard deviation are not given, let your mean be 0, and then let your standard deviation be 1. To find this command, we're going to hit second and then bars, but I will show you that in just a moment. But this only applies if it's less than, also known as shaded to the left. This command is used when it's shaded to the right. Once again, you have a normal bell curve. Your x value is whatever it's greater than. But in this instance, since it's shaded to the right, you know you have a positive infinity, which will be represented by positive 10,000. So your lower bound would be x, whatever it's greater than. Your upper bound would be 10,000, and then once again you have your mean and standard deviation. Then you have between. Notice how it's shaded between. This is generally what the normal CDF function is. So this would be normal cumulative distribution function, where your lower bound is whatever is given, your upper bound is also given, and once again you have your mean and standard deviation. However, let's take a further look and how you use central limit theorem. Another way of looking at that will still be using your normal cumulative distribution function, where your lower bound, upper bound, and your mean. However, your standard deviation would be divided by the square root of your n. This is also less than, because once again, you know so because it is shaded to the left. When it is greater than, notice how it's shaded to the right. Your lower bound would be x, upper bound would be positive 10,000, then you have your mean, then your standard deviation divided by the square root of n. My apologies for the blurriness. Hopefully you'll be able to make it out. And then lastly, you have your lower bound, upper bound, standard deviation divided by square root of n. But let's not forget our mean. This is only if a sample size is given to you. So let's see how we can use these calculator commands using the calculator. Each scenario would be very different, so make sure you pay close attention to what's being given. So if we're given one where it has a lower bound and an upper bound given to us, we would be using the normal CDF. Notice how you never use a normal PDF. To find the command, hit second, bars, use your down arrow key to normal CDF. Those of you who have an older version of the TI-83 or TI-84, you will actually type it in as the way it is written, using the parentheses and commas. For the more up-to-date version, once again, depending on what is being asked, is it less than, greater than, or between, you have to make sure that you know what your lower and upper bounds are. So if it's less than, you know that you have a lower bound of negative 10,000. Upper bound is whatever is given, so we're going to say it's 51. Then we have a mean of 49 and a standard deviation of 12. These are just some random numbers that I'm showing you, but again, make sure that you pay close attention to what's given. So notice how I had an syntax error because my numbers are wrong. So let's try another example, still using the exact same command. So negative 10,000, and I saw what my mistake was, so my apologies. So for future reference, make sure you know the difference between your negative is listed right here and your minus. And there we have it. This concludes the video tutorial showing you how to use the normal CDF function using the TI-83 and TI-84.